Okay, looks like we're going to get started here on right triangle trigonometry, and this is just the introduction. There are two other videos with this, and those videos are going to be talking about how to use right triangle trigonometry to find the side measurements of triangles and find angle measurements of triangles also. So let's go ahead and get started here. And let's talk about right triangle trigonometry. Let's go ahead and introduce it. Here's a real life scenario in which people do use right triangle trigonometry. If you look, this says, in order to manage and maintain forests, it is important for a forester to determine a tree's age, volume, height, and diameter. If you look at these two gentlemen, they have some sort of measuring device. Looks like maybe a tape measure. I'm not sure the technical term for that, but I think tape measure would be good enough. And they're measuring how the circumference of the tree. If we look here at the next part, on the left side you see a gentleman holding a hand up to his eyeball and he's looking at the top of the tree. And then on the right side, the little picture that's inset there, you see the guy is holding some sort of device up to his eye and he's looking towards the top of the tree. What this is called a clinometer. This little thing right there is a clinometer. Clinometer. And what that does is it gives an angle of elevation. It gives an angle of elevation. But when using a clinometer, you need to make sure that you pay attention that the clinometer is not on the ground. So this isn't an angle of elevation from the ground. It's an angle of elevation from the person's eyeball, which, is however high that is off the ground. So that's one thing you got to pay attention to with the clinometer. So what are these guys doing? They're calculating the height of the tree without actually climbing up the tree and, getting pine sap all over them if it's a pine tree, or, possibly falling down out of the tree and breaking an arm or a back, or even worse, like a face or maybe an ear or something like that. So the clinometer saves them from climbing up in the tree. So we're going to look at this next one. And let's use this situation here. Let's say, here's the situation. A clinometer is used to find the angle to the top of the tree is 57 degrees. So we know that this angle here is 57 degrees. The distance from the tree is 45 feet. So this distance of x is 45 feet. If the person using the clinometer is 6 feet tall, what is the height of the tree? Well, let's go ahead and calculate this. We're going to calculate h. We need to find the value of h over here. So in order to do this, now this might be something you two don't know how to do because this is right triangle trigonometry and this is what I'm trying to teach you at this moment. But follow me here. We're going to say the tangent of 57 degrees is equal to opposite over adjacent. The opposite side is h and the adjacent side is 45. So now if we look here, how are we going to solve for h? H is the variable that we're trying to solve for. So the opposite of dividing by 45 is multiplying by 45. If you multiply the right side by 45, you have to multiply the left side by 45. So in our calculator, we're going to use a calculator for this. It seems to be the most efficient way of getting it done at today's time. You're going to type 45 times the tangent of 57, and I want you to start getting used to the terminology. A lot of people, a lot of students will try and tell me that is 57. That is not 57. That is the tangent of 57 degrees. So make sure you say tangent 57 degrees. So we're going to, in our calculators, we're going to multiply 45 times tangent 57. And when you do that, you're going to get h is equal to 69.29. 69.29. And since 45 is in feet, this is also in feet. So 69.29 feet. Now we have to think here. If this is 69.29 feet and the person is 6 feet tall, we are going to minus 6. We're not going to minus 6. We're going to add 6, I believe. Because if, let me add more to the picture. Because remember, here's the tree. This distance is 6 feet. That distance is 6 feet. The angle of elevation from the clinometer from the person's eyeball is 6 feet off the ground. So that angle of elevation right there is 6 feet off the ground. So what we found with 69.29 feet was the value of h. And h only goes to where the angle of elevation started. So h only goes to that red line or the purple line that I just put in there. Well, if this tree trunk is 6 feet, there's more to that because the person is 6 feet tall. This angle of elevation is 6 feet off the ground. So this is the ground. And this is the eyesight. The eyesight that they're looking there. So instead of minusing 6 feet, we need to add 6 feet. So that's going to be 75.29 feet. So we'll say it's approximately 75 feet tall. And I can tell you that took us a lot less time than trying to climb up that tree. Unless you're a squirrel. And if you're a squirrel, then you climb up it pretty quickly. Squirrels climb up it pretty quickly. So if you're a squirrel, then you go ahead and hook a tape measure to you and run to the top of the tree and then measure it out real quick. And I guess it's not that bad. But I'm not a squirrel. If you're listening to this, you're probably not a squirrel. So trigonometry, helps us out here. In right triangles, sine, the abbreviation for sine is this. Cosine, the abbreviation for cosine is that. And tangent, the abbreviation for tangent is that. In right triangles, sine, cosine, and tangent are used to determine missing angle measures and or side lengths. So if we look at the picture on the left, the yellow triangle, with the given information that we have, we can calculate. If we have 30 degrees and the hypotenuse is 15, we can calculate what x is, we can calculate what y will be. And then of course, if this is 30, we know this missing angle measure is 60 degrees. 60 plus 30 equals 90, and then you add this right angle to it, that's 180 degrees. So I mean, finding the third angle is fairly easy for you. But if you look here in the green, we don't have any angles, but we do have two sides. So with those two sides, we're going to be able to find the hypotenuse. I'm going to put a letter C there. But also, with those two sides, we will be able to use sine, cosine, or tangent to determine x and y. We'll determine what those angles are. And actually, you can find one angle, subtract it from 90, and that should give you the third angle there, kind of like we did here with 30 and 60. So that's what sine, cosine, and tangent are going to do for us. So let's go ahead and look at some of these vocabulary terms here, or formulas actually. So sine, now let's start with sine. It says sine, and the formula is sine of theta. And this right here is a lowercase letter in the Greek alphabet called theta. You've probably seen these on fraternity and sorority houses. You've probably seen them maybe in some other math courses. These are Greek letters, and in this one we use the word theta, and all it represents is just the angle that you're going to be using. So it just represents an angle that you're going to be using there, or an angle that you want to find the angle measurement of. So let's go back to the formula. It says sine, or, wow, slow down here. It says sine of theta is equal to the opposite leg over top of the hypotenuse. And as long as you can set that up, then you can use your algebra skills to solve for the unknown, whether it's the angle, the opposite leg, or the hypotenuse. The next one down, cosine. So the formula says cosine of theta is equal to the adjacent leg divided by the hypotenuse. And the last one here, tangent. Tangent of theta is equal to the opposite leg divided by the adjacent leg. Now, you're probably going to have to understand how to determine what these are, and then we're going to get to that here in a moment. But these formulas, if you can have these formulas memorized, there's a little saying on the next slide that will help you to remember it, but it's important to be able to say these. It's important to be able to just recite these. If you can do this quickly, then it saves you a lot of time when calculating angle and side measurements of a right triangle. So this next slide shows basically the same thing, but it has this little saying up here. SOHCAHTOA. SOHCAHTOA. Now if we look here, let's look at S-O-H. What does that mean? S stands for sine. O and H stand for opposite over hypotenuse. So sine of theta is equal to opposite divided by the hypotenuse. And if you can remember, so uses those letters, then the formula is memorized for the most part. Theoretically speaking, you have it memorized. But now, if you think about it, you have to remember how to spell SOHCAHTOA. I've had some people in the past that couldn't remember how to spell SOHCAHTOA, and then they got the formula wrong. So either memorize the formula, memorize how to spell things, or you're going to have difficulty solving these. Let's look at cosine. So, this is the c part. Cosine starts with the C, so does c. So this says, look at the c. Cosine is adjacent over hypotenuse. And we look here, adjacent over hypotenuse. That's where we get the A and the H. And the last one, TOA. SOHCAHTOA. TOA. T stands for tangent. O and A, right here. Opposite over adjacent. Opposite over adjacent. SOHCAHTOA. If you can get that figured out, if you can get that memorized, either the short little saying to remember it, or the formula, one of the two. So in order to use right triangle trigonometry, you have to have these memorized. For the problems that we're going to be doing in video 2 and 3, you're going to want to keep these handy, because I will address these, but you need to be able to look off these for your own problems that you'll be doing on your own. This next slide here, I am going to ask you to label the sides as the opposite leg, the adjacent leg, and the hypotenuse. So we have adjacent leg, opposite leg, and hypotenuse. On the left triangle here, when you go to label opposite and adjacent legs, you have to first start out with an angle. So you have to identify the angle that you're going to be using. So in this case, we're going to say theta is equal to 60 degrees. On the right side, in this case, we're going to say theta is equal to 30 degrees. And I want to show you that we have the same triangle both on the left and the right. That's the same exact triangle. But for each triangle, you have to pay attention to the angle that you're using because opposite and adjacent legs will be different depending on the angle that you're using, and that's an important aspect that you have to notice. The hypotenuse is always the same. The hypotenuse is always across from the right angle. So the hypotenuse is right here. HYP, I'm going to abbreviate that as hypotenuse. Hypotenuse is always across from the right angle. Now, if we're using theta to be 60 degrees, the opposite leg is always across from the angle we're using. So then y will be, I don't like that equal sign there. So y is going to be the opposite leg. I'm abbreviating that as opposite, OPP. And now adjacent means it's going to be right next to it. If we look, I'm going to highlight the sides adjacent to the angle, 60 degrees, and I have those both in purple. And if you notice, the right side is the hypotenuse, and the one on the left is the adjacent side. The x value is the adjacent side. So the adjacent side is always part of the angle. There's always one side that forms the angle. So that's if theta is equal to 60 degrees. Well, let's go to the right side here. Theta is equal to 30 degrees now, so we're going to be using this 30-degree angle. 15, once again, is the hypotenuse. I typically always try and label the hypotenuse first. And now let's go ahead and label the opposite side. Opposite side is across from 30 degrees. So x in this case is opposite. And the adjacent side, remember the adjacent side is going to be a side that forms the angle. And here's the angle. And now the two sides that form the angle, one's the hypotenuse, the other one is the adjacent side. And so we've just labeled those as opposite and adjacent. And I want you to pay attention to this. If we look, when theta was equal to 30 degrees, x was the opposite. But when theta was equal to 60 degrees on the left side, x is equal to the adjacent side. So that's why you have to identify which angle you're working with first. And then you can label your opposite and adjacent sides. So this is a good step here, labeling opposite and adjacent, figuring out which angle you're working with first. This next slide, I want you to try this on your own. I want you to try this concept on your own and labeling sides as opposite, adjacent, and hypotenuse. First off, let's go ahead and identify what theta is. Theta in this case, we'll pick an angle. Your angles are either x and y. You never use the right angle. You never want to use the 90-degree angle there. So theta is going to be x. And over here on the right side, theta will be y. And so now what I want you to do is I want you to label the opposite leg, the adjacent leg, the hypotenuse. So pause the video and label it, and when you're done, press play and then check to make sure that what I put up here is what you put up there. All right, I'm going to work on the left. The hypotenuse is always across from the right angle. So there's the hypotenuse. Now, since x is theta, the side across from theta will be the opposite side. So 24 is opposite, and 18 is right next to the angle, so it is adjacent. On the right side here, Since y is theta, go ahead and label the hypotenuse first. It didn't change from the left triangle. It's still across from the right angle. Now, since y is theta, the side across from it is 18, and that's the opposite side. And the side right next to the angle is the hypotenuse. Remember, don't get the hypotenuse confused with the adjacent leg because they're right next to the angle. The hypotenuse is always across from the right angle, and the other side that forms the angle. See, there's the angle being formed. The other side, 24, is the adjacent. So there we go. That's what we have. So this is the first step into doing right triangle trigonometry is identifying adjacent legs, opposite legs, and hypotenuses. That's all we have for this video. We have 2 other videos in this series for right triangle trigonometry. So check those out, and hopefully you can get to calculating some trigonometry there. Appreciate you stopping by, and we will see you next time.